Okay.
Yanda Zhang, Dr. Yanda Zhang, is the CEO and founder of ZYD Energy Incorporated. ZYD Energy provides advanced control solutions for water heating systems to achieve load flexibility and efficiency optimization. Yanda has more than 15 years of experience in the energy efficiency industry. I saw him present in 2013 and he blew my mind at the Hot Water Forum. I've been following him ever since. Previously, he worked as a technical director at HMG and TRC, leading and managing consulting projects in building energy science research, technology assessment, codes and standards development, program evaluation, and policy analysis. Dr. Yanda Zhang. Woo!
Well, thank you for the introduction. just speaks of that when you're working for, especially at the beginning, a small, relatively small consulting company, you just have to do everything, another choice. So just adds a little more to your introduction. Actually, before that, I was working for GE, General Electric, not working on their water heaters, but on power plants. You know, when I joined energy efficiency side, and the people you always joke that I came from the dark side. But that might be extra, you know, it's too much, but I definitely enjoy my, you know, later career in energy efficiency than in my power plants like world. So.
There's a role, there was a time in your life, it was good. We're all glad we have power plants, but I think what you're doing here is excellent. I mean, taking the knowledge of the importance of grid flexibility and what you learned from power plants and doing it now.
Yeah,
anyway.
Yeah. So it's all related to power. So, Sean, when do you want me to stop?
At 3 o'clock, if you could. And
okay, 3 o'clock.
After
cool.
you, Maria Diaz will be presenting, so you can go a little bit over because her presentation can be squished a little bit if you need to, and etc. So just so you know.
Okay, yeah. So yeah, today we're going to talk about load flexibility and energy efficiency optimization for central hot water heating system. So this is related to a new technology that we're developing. So first of all, water heating is important for residential homes. And this is kind of like a slide that I borrowed from a recent presentation by Energy Commission on their 2019 ROS residential appliance saturation study. And you can see that compared to 2009 RAS study, which is 10 years ago, that the fraction of natural gas used by water heating has been increased from 48% to almost 60%. Might be because homes getting bigger, people like, there's still a lot of questions, right? Why is the reason? But as Sean pointed out, maybe has also a lot to do with, you know, a lot of system just probably doesn't work properly as installed. Nevertheless, this is the issue we have to deal with. This is the energy component we really have to address to achieve zero carbon, right? So central systems, mostly, right, they're used in apartment buildings, hotels, motels. They're complicated. Not to show in this slide, trying to go through the diagram, but it really just trying to indicate central systems are complicated, and there are more and more central heat pump water heaters available. So given the choice of different equipment you can choose and different design configuration you can have, even you may want to even think how you want to consider integrating with solar water heatings. So things are getting more complicated. Just to design a central heat pump water heater system itself is already challenging, but we also need to deal with the next level is to basically make the system achieve load flexibility to reduce impact on the grid. So we all know the duct curve, right? The key point is that we need to avoid the usage during the peak. Not only that, if we want to truly achieve zero carbon, we also need to align water heater operation with kind of the carbon intensity of electricity supply, right? This is a kind of high level overview of what is going to be expected, 10 years down the road. Yes, our grid is going to be definitely get cleaner. The green spot, all the green like squares representing the time when we have low carbon electricity supply, but we still have many hours that we have relatively high carbon intensity electricity supply. So we need to avoid use of those electricity, right? So speaking of that, that means that we have to control the heat pump water heaters really at the granular level to align with carbon, electricity supply conditions. Okay, so that really require, just calls for better controls. So I like to introduce our technology, and we think, there's going to be a lot of technology available. This is going to be hopefully one of the ones that are contributing to the course, right? So the technology is called Locus Technology, stands for Load Optimization Control Using Storage. Previously, we called it Thermal Storage Control. It sounded like too generic, so we came with this new acronym. What's the key difference here compared to what we already have, right? So what do we have today in terms of dealing with load flexibility is what I would call temperature control. So what you do is that before the peak hours, you increase the set point of your heat pump water heater. So in a sense, supercharge your heat, the heat pump water heater to store with high temperature hot water, right? So that during the peak hours, you would have more than enough, hopefully, right? More than enough hot water to get by without triggering the heat pump operation, and hopefully, don't even trigger the electric resistant backup heating. So, and we have a different approach. The approach is that if you look at this diagram here, that we use part of the system storage as kind of dedicated load control storage. It connects with the heat pump water heater through we call it manifolds, adjustable connection manifold, right? Such that the system, overall, the system can operate in multiple modes. I will explain that. Instead of traditionally, or as what we have today, we have basically static system configuration. And with this configuration, we achieve more dynamic system configuration. You see this manifold consists, includes some electrically controlled valves and a circulation pumps. Right? By controlling those components, we change the configuration of the system. So let me show you how we did that, right? How we're going to do it. For example, I'm showing 5 option mode you can achieve. In one mode is that we use the heat pump water heater to charge the storage, basically fill it with hot water, right? At the same time, the cold water at the bottom of the storage will be pushed into the heat pump water heater to trigger heating. So the heating operation of the heat pump water heater will be basically controlled by this charging mode, and controlled by how much cold water you kind of circulate into the heat pump water, right? It's almost basically as you charging a battery. So it's a charging mode, right? Once the storage has enough hot water, we can use it to supply hot water to fixtures. And the configuration works in such a way, I didn't show all the details, that it configuration it works in such a way that the heat pump water is disconnected basically from the fixtures. So even you taking a shower, you have your dishwasher running, and the heat pump water heater will not fuel it. Therefore, no heating will be triggered. So all the hot water demand will go through the storage. So it's kind of you think about it's almost like a discharge, just a battery. You know, the heat pump water heater, it's like working as a charger here. And we can, you know, have a mode, you know, when, for example, when the storage is full, we decide to save it for later, but we're going to use the heat pump water heater to supply to the demand. So to save this storage for later use, especially say for a peak time use, right? Or if the storage is completely depleted, you have like empty battery, you don't have to charge it right away because you think, well, maybe it's night, the carbon intensity of your electricity supply is high. Let's not charge it. We can do it later, right? When the sun's up, let's do it, right? So also we can have a mode that we basically put those two in series, and so that you can fully use the hot water in the storage and pushed into the heat pump water heater and supply it to the fixture. And this is kind of useful when your demand is high, right? That you want to use all the storage you have. So here are the example modes, but they don't have to using any particular sequence. So it really depends on your situation or expected demand, expected electricity price, and expected carbon intensity of your electricity, right? So this is by using different combinations, we achieve kind of the optimized load control and efficiency. So again, it's quick comparison of our technology, Locus control, to traditional temperature-based control. That you know, you can already see, you know, our control is more about, you know, basically it's kind of its capacity in a sense is determined by the size of the load control storage, right? Compared to the temperature-based control, your load flexibility capacity depended on how much you can raise up the temperature, right? And our control increase efficiency at the same time when we achieve load flexibility, and temperature control usually, well, not usually, will decrease your efficiency because it will use a high temperature setting point. We know that, right? Heat pump water heater is sensitive to temperature output. Also, our control, let me go back to maybe the last previous slides. It doesn't have any particular requirement on the heat pump water heater itself because it triggered the operation by putting cold water into the heat pump water heater. It doesn't need to change any temperature set point, doesn't need the required heat pump to have any special control, right? So therefore, we can use it for all heat pump water heaters. We can use, this is what I'm going to talk more, we can use it for central heat pump water heaters. And so far, I have not heard about maybe any scheme that using temperature control for central systems. So here are the prototypes we developed, and this system, first of all, this is not central system, but this is for prototype designs. And by the way, for this presentation, we're going to focus on central system, but we actually are also developing a system for single family use. This system is actually in my garage. I basically use my home as in a sense, a testing bed. So this is a further version, and we have our own controller, custom-made controller to achieve control optimization. And so here's some or just a quick example of what we are trying to achieve, right? What we can do. So for example, in the left diagram shows system operation without locus control. And the blue dot shows kind of the random hot water use throughout the day, and which triggers, right? So you see that hot water use trigger the heat pump operation. The red dot shows the current used by the heat pump water heater. And if you have high usage, this during midnight-ish, it triggered actually electric resistance heating. And the green dot shows the PV panel production. And we can see that the heat pump water heater usage, mostly, right, they're not aligned with our solar production. Once we have the locus control, so this represents one of the control output, that we basically, the usage is still kind of random, there's a lot of nighttime use. But we may be able to make it to operate mostly during solar production time, right? Also, we get rid of the electric resistance heating. Even here we have high usages. So yeah, so this is basically the outcome of both low flexibility and efficiency improvement. And from a system integration point of view, we also have IoT-based, database system connect to our control, allow us to further connect to grid control signals, and so that we can our optimization software can use the say like real-time electricity price and electricity carbon intensity values, right, to perform operation optimization. So I'm going to talk about now. So going to do really gets into this central system, right? So what we showed is really the basic concept of the locus control. So what are we going to do? What we can do for central systems? Step one I'm trying to show you is that this technology can be scaled up for large systems. Instead, if you have one heat pump water heaters, you can have multiple ones in your system. You could have multiple storage, right? It just so that we have more connections and to such that each heat pump water heater can be individually controlled and connected to the storage. And at the same time that you can see that if we put all the connection in a sense of packaged units, for example, like this, right? The system configuration and connection is actually greatly simplified. All you need to do is connect your hot and cold to the corresponding port of this kind of like control box, right? And you can connect the storage code, hot and cold, to the storage side of the connection and your city supply and hot water supply. Therefore, it makes your system design and installation pretty simple. And basically, you just need to get them connected. The control will optimize operation for you, right? And next step, let's look at what if systems that realistically, our central system oftentimes include a recirculation loop. This has been to a degree a headache for central heat pump water heating systems, right? Especially for heat pumps that is designed for single pass operations. Those heat pumps does not like, lukewarm water coming back from the recirculation loop, right?
just to interject people, single pass, an example would be the Sanco 2 carbon dioxide heat pump water heater that Wei Tai showed on his house. That's a single pass. It doesn't want warm water coming back versus
Right.
other heat pumps that can handle that, like a 10-degree temperature difference. But sometimes it comes back only 1 degree different, which messes up any heat pump. Doesn't matter what it is, just 1 degree temperature differences between going in and going out.
Yeah.
So this is very helpful to emphasize.
Yeah. Sorry, I didn't have time to maybe to go all the technical details.
You did a great job. No, great job.
Yeah. Yeah, single pass, but yeah, one thing to add on, single pass heat pump they're great. You know, they have very high efficiency compared to much higher, right? Compared to multi-pass heat pump orders, especially the CO2 based heat pumps. They use single pass design. And so it's critical that we should have system being able to use them, right? So it's critical. So, and how do you deal with that? Like Ecotope pioneered the design using a separate storage, temperature maintenance storage. They also you might heard about swing tank method. You basically the same concept, same thing. Use a separate storage to store high temperature, say 150 or 60 temperature, and use that in combination with a mixing valve to provide hot water for the recirculation operation. So that instead of you reheat this lukewarm water coming back from the recirculation, you mix with higher temperature to raise up the temperature, right? So there's a lot of little details in this process. Forgive me that I'm not going to be able to go through that details. The concept again here, this technology is that we can using this kind of this storage-based control, we can more actively control when the heat pump or heat is used, when the backup, especially the backup electric water heater is used, when we have to deal with the recirculation loop operation. And again, it has been complicated for people, but with this tech control, we can also make it to be simplified, right? Is again, we put all the control connection into into a package such that all you need to do is connect the plumbing from a design point of view, from an installation point of view, right? So leave the control, let the control to do the proper operation and optimization and load control for you, right? So same concept, if you can have solar or even gas water heaters, how do we integrate them? For existing home buildings, you may not be able to remove your gas water heaters completely for various reasons, right? For example, you might want to use just the one gas water heater as some kind of peaker, right? To deal with the large demand. You don't have to make the size the heat pump to be very large, so they can save costs, right? So again, same concept. We can help you to integrate things together. All you need to worry about is just what the overall capacity you need, what's overall storage size you need, and we get them connected and get them run properly.
And you're at 3 o'clock. If you could.
Yes. So, just pretty much my summary that the technology aims to achieve 3 things: load flexibility, energy efficiency, optimization, and system integration, right? So the key we want to do is to make it the low flexibility available for all type of heat pump orders and system designs. That's all I have.
Woo!
Thank you.
Brilliant.
Thank you.
Brilliant. I hope everyone hears that. That's a very helpful presentation of like idealized thermal storage. I don't know if Yanda, you were able to see Dr. Dre at the beginning of the day, Dre Helms, but they were talking about some of the same issues you're dealing with, but from the phase change material perspective, how to
Mm.
get that kind of storage. Just it's been a really good day for those kinds of presentations. So if you could hang out over and chat, if people have questions for you.
Yes.
Thank you very much. And just so people know, I'm going to get to work with Yanda on multiple projects over the next 4 to 5 years, down in SoCal Edison territory, up in PG&E territory, as we try to crack this nut to really get rid of peak energy use by the central heat pumps through storage strategies and controls. It's like, we all know this is very important.
Yes.
Okay, thanks, man.
Thank
Appreciate
you.
it.
Thank you, Sean.
Absolutely.